Good day. We are Group 9 and we are undertaking the problem of dielectric spectroscopy and how it can be used to assess the nitrogen content in fruits and vegetables. Dielectric properties of materials are important in determining how electromagnetic energy in the radio frequency and microwave range interacts with materials, and the study of their dependence on wavelength or frequency is termed dielectric spectroscopy. With regards to fruits and vegetables, interest in dielectric properties has been associated with only a few applications, with the main use being in quality measurement. In connection with quality sensing in fruits and vegetables, the dielectric permittivity of the fruits and vegetables were measured using an open-ended coaxial probe. The term permittivity implies to the complex permittivity, that is, the permittivity of the material relative to free space, called complex dielectric permittivity, which is expressed in theoretical form, where E' is the dielectric constant and E" is the dielectric loss factor. The dielectric constant is associated with the capability for energy storage in the electric field in the material, and the loss factor is associated with energy dissipation in the material, or the conversion from electrical energy to heat energy. Hence, all loss mechanisms, both due to dipole relaxation and ionic conduction, are included in the dielectric loss factor. The open-ended coaxial line probe technique can be used to obtain the permittivity if solid dielectrics have broad ranges of frequency by measurements of samples. The probe was used with a network analyzer to estimate permittivities. Two models of coaxial probes used were the Hewlett-Packard and ammonium probe. The coaxial probe is modeled to obtain a formula for capacitance as seen in the theoretical formula and system model. On preparation of the fruit sample, all measurements were taken as seen in the table, and capacitance was calculated using the permittivities. Due to the probe being modeled after the Hewlett-Packard and ammonium probe, we are able to measure nitrogen concentration. These parameters were plotted on a logarithmic scale of capacitance versus nitrogen concentration. From the results, it can be seen that a constant decrease in dielectric constant from 10 MHz was experienced. In addition, there was an increase in loss factor as temperature increased, and an increase in dielectric constant and loss factor resulted in an increase in nitrogen content. This can be observed in the graph where as capacitance increases, nitrogen content increases. Hence, our problem is solved as dielectric spectroscopy can be used by means of a coaxial probe to assess the nitrogen content in fruits and vegetables.